Monday, Wednesday. Wednesday you had bio, right?
Yeah. Wednesday,
Did you
8
get
p.m. India time.
8 p.m. India time?
But that was just my first class, so I was the only person in the class. It was just
that was
me.
a demo. Okay.
Yeah.
So did you get any?
And then yeah, with the batch, after that I did again on that same day. That was 9 p.m. India time.
Okay. 9 p.m. IST.
Yeah.
Okay, this is Monday, Wednesday. This is for biology, right?
Yeah.
And for physics, you do Tuesday, Thursday, I guess, right? You were
Yeah,
in the
but
batch?
then I didn't do it with the batch yet for physics. It was just demo
so you
class.
haven't. It was just a demo class.
Yeah.
And so, who took your demo class?
For physics,
it
was Amna.
Amna ma'am. So she did not tell you any timings. Did she give any timings?
No, she didn't say anything.
Sure. You must be having some like. Did she also tell anything like if you are going to join this batch, then this much portion is over or completed, and you have to?
Yeah, she told me, but she said it's okay. Like on the first class, she like explained some stuff, and she was like, from the next class, you will be able to understand.
But not about the pre. I mean, maybe it's a new batch.
No, in bio, she said they didn't do much, so she explained everything, and then from the next class, I was able to catch up.
Achha, fine. So in bio, it was a new batch, but you have not done any.
Yeah.
So maybe do one thing, like I will put you up on Saturday, Sunday batch most probably for chemistry.
Okay.
And then you have to watch a few lectures for chemical bonding. But I think chemical bonding. Have you done any have you covered anything by yourself right now?
In school, chemistry? Yeah, we finished the first 2 chapters, some basic concepts of chemistry and structure of atom.
Okay, that's it.
Yeah, we did that. These 4 chapters. It's okay. I can watch videos.
No, you can watch videos, but I mean, you have done only 2 chapters. You must have idea about something electronic configuration, how to write electronic.
Yeah, I have the idea. I have the idea about it.
Okay. Then I will message you. I mean, maybe we'll talk about like how to complete those things, and maybe I will put you up on the Saturday, Sunday batch. Monday,
okay.
Wednesday, you are having at. So let's see when I have. Tuesday first. Let us do this first chapter.
Okay.
So in the last lecture, I hope you revised. Whenever we do a lecture, all of you guys, please revise it. Okay. And when I say revise it, don't just read it. And try and have a blank sheet with yourself. Try to note down the important points. Try to read the questions that we did in the class. That is revision. If you are just going through, if you are just reading it, that is not revision. Okay. So whenever you revise something, take a pen and maybe note down important points. And then what you should do next is redo those questions that we did in the class. Okay, so that is proper revision. Otherwise, if you are just looking at it, it is not revision. You are not going to be able to remember many of the things like that. Now, in last class, we saw that there are 3 formula that we need to use for number of moles. And it is depending on what is involved in the question. For example, if number of particles involved, then the given number of particles, given number by Avogadro's constant, right? This is going to give you the number of moles. Then if mass is involved, That will be the given mass divided by the molar mass. Next, if you have, let us suppose, we have volume at STP of gas. This is only for gas. And in that case, we are going to look at given volume divided by 22.4 liters. If only one of the things is involved, so you're going to write number of moles is equal to given mass by molar mass or something like that. But let us suppose they are asking you to interconvert between number of particles to mass, then you will write this equation and this equation, then equate them. So in that case, you will get the number. And the things that you should know here is Avogadro number is constant. So this will be equal to given number, whatever the given number of particles, divided by 6.022 into 10 to the power 23. Now the given volume is also the molar volume is also a constant, that is 22.4. But you need to remember the molar masses for a few elements. Most probably in the school test, and also when you go to 12th standard in board examination, there also you have to calculate, indirectly you have to calculate number of moles to do some further calculations. So in that case, they will be giving you the molar masses. Most probably they will be giving you the molar masses. But if it is something like H2O, so they expect you to remember the molar mass of H2O and simple compounds. Okay. So in the last class, we had some simple compounds. So if you don't remember much, try to remember at least these. Okay. That at least 10 of these should be in your head. NS3, HNO3, H2SO4, CaCO3. Maybe remember these things and it will be fine. So moving on. Next part, that is the concentration term. And why do we need concentration term? It is because we are going to study about solution. Whenever we do any reaction, most of the reactions are done in solution, inside water, in chemistry. That is why we have to learn about solution. Please write down. Write the heading solution. The solution is a homogeneous mixture of two or more substances homogeneous mixture of two or more substances. Two or more substances, and we are going to look at only specifically looking at solution with two components, in which we are, let us suppose we are adding water, and in water we will be adding salt or something. Okay, this is water, and which is present in larger amount, that is known as solvent, and which is present in minor amount, that is known as solute. Okay. So all of you must remember solvent and solute from which standard? From the 9th standard, I think you learned about solvent and solute, right? The first, second chapter, right? Is matter around us pure? So in that you must have learned about solvent and solute. Solvent is present in major amount, and I will refer solvent as A, and I will refer solute mostly as B. Many of the books, they refer solvent as 1 and solute as 2 also. Okay, so don't get confused by that. It's simple. A, B, or 1 or 2. Now, you'll write here, in solvent, you will write present in larger amount. This is present in lesser amount. Next, you must have been introduced with concentration terms in the 9th standard also. Please see. Concentration terms. So what is concentration term? It gives an idea about amount of solute present in certain amount of solvent or solute. Present in certain amount of solvent or solute. sorry, solvent or solution, my bad. Solvent or solution. So if you imagine when you are going to make tea or you make ruafza or something like that, then sometimes they give you, if you are going to make 5 cups of tea, then put this many teaspoon of the tea leaves. So in that case, we are talking about tea, that is a solution. Right? But sometimes they will give you information. If you have 2 cups of milk, then add this many spoons of tea and tea leaves. Right? So solvent, and sometimes they will also tell about the solution. Now, one concentration term that you must have learned in the 9th standard is mass percentage. Mass percentage, it is known as, it is denoted by percentage W by W. And the percentage W by W, it is equal to if I talk about solute, this is equal to mass of solute divided by total mass of solution multiplied by 100. Okay. Now, more than formula, what is important? Please note, if you have X percentage of aqueous, let us suppose you have aqueous NaOH by mass. Okay, so when you have been given X percentage of aqueous NaOH by mass, then maybe this number may be 2, 3, 4, 5, 6, 7, 9, 8, 10, 11, 20, 30, you know, whatever that number is. It means X gram of NaOH is present in 100 gram of solution. Now, with this particular one number X gram, you will get the mass of different, you will get the mass of solute, solution, and solvent also. So mass I will represent by W, and when I write B, that means mass of solute will be equal to X grams. Mass of solution will be equal to 100 grams. And the mass of solvent will be equal to 100 minus X grams. Is this clear? Yes or no? Please tell me.
Yes, sir.
Now, let us see a question. If they say 27%, please. W by W, 27%, W by W of HNO3 solution. So first you will tell me what is the mass of solute. The solute is a nitric acid here. Secondly, you will tell me what is the mass of solution. And thirdly, you will tell me what is the mass of solvent. If 1, 2, 3, please send me the answers in the chat. Take not more than 2 minutes. Send your answer on Zoom chat. You guys have 1 more minute. You just need to plug in the values here. No? If X percentage is there, that means X gram. 27%, then how many grams? When it is percentage mass, then it is solution is going to be always 100 grams. And then you need to just calculate the mass of solvent. What happened? I did not get any answer. Abdul Hamid, Khudeja, Mariam, Yasir. Did you understand this? Abdul Hamid, Khudeja, Mariam, Yasir, yes or no? Tell me. Yes, Mariam.
Sir, can you explain again?
No, can you please read that? X percentage of aqueous annuaged by mass. What does it mean? Read it. It means I can't hear you, Mariam.
X gram
X gram of
NaOH is present in 100 grams of solvent.
Solvent.
Solution.
Okay. So instead of X, what do we have here?
27%.
So what will you? What would it mean? 27.
So it will be 27 grams
Of
HNO3
is present in.
present in 100 grams of solution.
So just plug in the values. Now, what is WB meaning? WB means what? W means mass. B means
Solute.
okay. So what is the mass of solute? 27%.
20, yeah,
27 gram, right?
27 grams. Okay.
Mass of solution. Hope you know this.
100,
right? I mean,
100 grams.
100. Yeah. And mass of solvent is
100 minus X. So it will be 100 minus 27.
so it will be
23.
how much? 100 minus 27.
70. 660.
See, it's very easy if you want to subtract these percentages. Also, I won't know. Let us suppose you have 100, right? And you have minus 67. Okay. So you don't need to do anything. You subtract, sorry. Let us suppose you have 27.
73.
Not 73. See here. If you have 27, okay. So you subtract the first number by, this is 10, right? 10 minus, 27, right? So you will subtract this particular number by 9. How much is this? Tell me. 9 minus 2 is equal to how much?
7.
7. And then you multiply all of the numbers by 10. So 10 minus 7 is equal to 3. Got it?
Oh.
For example, if you have 1000 minus 892. So first number by 9, so that will give you 1. Next number by 10, that will give you how much? 1. Next number by 10, that will give you 8.
8. Okay.
Okay. Also listen. Let us suppose you have 1000 minus 62. Okay. So here we have 3 zeros and only 2 digits. Here we had 3 zeros and 3 digits, right? So in that case, you will directly start. But when there is a difference between the zeros and the numbers that we are subtracting, then you will start with 9. Add a 9. So how many what is the difference here? The difference is of 1 0. So you will add a 9. Here we had 3 zeros and 2 digits, right? So difference is 1, so you will add 1 9, and then the same pattern will repeat. Subtract 9 and 6, you will get 3. Correct? Yes or no? And then subtract 10 minus 2, that is going to give you 8. You can also confirm this. 1000 minus 62, 938. Got it? Anji, bataye.
Yes, sir.
Okay. So you
Yes.
have not, I think Abdul Hamid has also not done, but I did basic maths calculation classes. Okay. So in that I did many things. For example, how to have, I started with a very basic idea about anything to the power 0 and everything is equal to 1, power rules, and multiply by 10,000, how to shift decimal point, and that's all. These are easy things that you must know. But after that, subtracting from 1000 and 100, so you can see 10 to the power n minus any n digit number, subtract all digits by 9 and last digit by 10. That is a trick. Division by 2. There are certain tricks. Multiplication by 5, multiplication by 1.5. Multiplication of 2-digit has a trick. And we expanded more on those multiplication of with 11 and square of 2-digit numbers that end in 5. Okay. And so if you want these lectures, you please message Learnivio and they will give you, they will send you the playlist of these basic maths things. Okay. So division also we covered a bit. And I think after that I covered logs. Okay. So log and anti-log that will be used for mostly in the thermodynamics chapter. There will be logs and anti-logs. Then in equilibrium, you will have a lot of logs and anti-logs. So please कितना पढ़िएगा लेकिन आप लोग कितना लेट हो गए आप लोग थोड़ा ठीक है पढ़ने के लिए बहुत कुछ है वैसे तो चलिए 27% yeah, fine. Now let's move on to the next one, that is, so this will be equal to how much? 73 grams, right? And I think Yasir did answer this. Yeah, Yasir, correct. Second is volume percentage. Second is volume percentage. Now, what is volume percentage? It is the same thing. If they are writing something, for example, X percentage V by V, this is percentage V by V. X percentage V by V of aqueous ethanol. Then here, aqueous means water. Okay, aqueous means water. So volume of solute will be equal to X ml. Volume of solution will be equal to 100 ml. And volume of solvent will be equal to 100 minus X ml. Please write this down. Same logic here also. Third one is mass by volume percentage. Is that the third one? Mass by volume percentage. Now, in this case, if you have been given X percentage of W upon V of, let us suppose you have aqueous NaCl, then in this case, you will get the mass of solute. That will be equal to how much? That will be equal to X gram. And you will get volume of the solution. This will be equal to 100 ml. Now, when you have grams and ml, so obviously you cannot subtract them. If you remember the first chapter, unit dimension and measurement of physics, in that you must have learned that you can subtract or add. You can subtract or add what type of numbers? The numbers which have same units. Right? If they are having different units, you cannot subtract or add them. Okay, so X grams and 100 ml. We are only going to get two information from mass by volume percentage. After this, write the fourth one. That is parts per million. Also known as ppm. In ppm, you will see the parts per million, and we have learned mass percentage. In percent, when we had percent, we used to multiply mass, the whatever mass of solute divided by mass of solution into 100. We are going to do the same thing here. We're going to do the same thing, but since we had percent, we multiplied by 100. Here we have per million, we will multiply by million. So ppm is equal to parts of solute divided by parts of solution. This will be multiplied by 10 to the power 6. Multiplied by 10 to the power 6. All of you got this? Yes or no, please tell me.
Yes, sir.
Now also please see, I can write this as parts, same thing here, divided by same thing here, into 10 to the power 2 into 10 to the power 4. Correct? Yes or no? Please tell me. Don't write this. Listen first of all. I can write it like this. Yes or no?
Yes, sir.
Okay. So 10 to the power 2 will be is what? 100. Correct? Now this, if I take parts as mass, then mass of solute divided by mass of solution into 100. This is nothing but this is mass percentage, right? Into 100, this is mass percentage. Mass percentage into 10 to the power 4 will be equal to ppm. This is the relation that you can remember. Then everyone is on a piece of me. All of you done? Guys, done. Yes or no? Let me know if 1 minute.
Done.
Write the fifth one. Please write mole fraction. Mole fraction, it is represented by, it looks like x, but it is chi. It looks like x, but it is chi. It's fully period, this is chi. So what is mole fraction? You see, we have two different components. We have solute and solvent. So if I want to calculate the mole fraction of solvent, this will be equal to number of moles of solvent divided by number of moles of solvent plus number of moles of solute. Actually, it is total number of moles in the solution. And in solution, since we have only solute and solvent, I will write Na plus N. And similarly, if I want to write chi B, so please see, mole fraction of A is equal to number of moles of A. So mole fraction of B will be equal to number of moles of B divided by the same thing, the total number of moles, that is number of moles of A and the number of moles of B. Now, there is an important part here. If you add both of these things, chi A plus chi B, you will get Na. Let me just copy this part. You will get Na upon Na plus Nb, and you will get Nb upon Na plus Nb, and you are adding both of these things, right? Now, both the denominators are same. That means we can directly, that means we are going to directly sum them up, Na plus Nb whole divided by Na plus Nb. Now, whatever the value of numerator that we are going to get here, we are going to get the same value for the denominator also. Yes or no? Please tell me. Correct? Hai? This value and this value will be same. Yes or no?
Yes, sir.
That is why I can cancel these two and you will get 1. So sum of the mole fraction of all component, it is equal to 1. This is the important conclusion. Okay. Now we were talking only about binary solution, but in general, if you want to write the mole fraction, please write. In general, the mole fraction of some ith component will be equal to the number of moles of that component divided by the number of moles of first component, number of moles of second component, number of moles of third components, and so on. No matter how many components are there, you are going to divide by the total number of moles. But we are not going to generally use this particular formula. We are going to use chi A plus chi B, but not chi A plus chi B. Rather, chi A is equal to Na upon Na plus Nb, chi B is equal to Nb upon Na plus Nb. But please remember, Na is solvent, Nb is number of moles of solute. Write this down. Let me know once you're done. लिखिए सबने हाँ या ना? All of you got this?
Yes, sir.
Yes, sir.
Write a question. Calculate the mole fraction of a glucose solution labeled 10%, labeled 10% W by. Okay. Now, first of all, as soon as you see this 10% W by W, you should be not seeing only one number, rather you should be seeing three numbers. What are the three numbers you should see? WB, this will be equal to how much? This will be equal to 10 grams. You should also see W of solution. This will be equal to how much? 100 grams. And you should also see the mass of solvent, which will be equal to 90 grams. Once you have listed these facts, then mole fraction of glucose. So what is glucose and what is its molar weight? Most probably you will be given the molar weight. And if not, then you have to find it out. Okay, so glucose has a formula. This is expected from you guys to remember the glucose formula because glucose was there in your 10th standard respiration chapter. Yes or no? And the life process was the chapter. The section was respiration or something like that, right? Yes or no?
Yes, sir.
Anji,
Yes.
Abdul Hamid. So क्या होता है glucose का formula? C6 H12
H12O6.
O6, right? And after that, you need to understand how to get the molar mass. Achha, one more thing, if you see here, we have got all WB, WA and all of these things. But if I talk about the molar masses of A, so what is A here? We have not been given any A. What is the solution? What is the solvent here? We have not been given. So we'll assume that the solvent is water. Whenever we don't have a solvent, then we will assume that the solvent is water. If it is not given, the solvent is water. So molar mass of water in the last class we have already seen it is equal to 18 grams, right? And if I talk about the molar mass of solute, this will be equal to how much? 6 into 12 plus 12 into 1 plus 6 into 16. हाँ जी. So 12 छक 72 plus 12 और 16 छक कितना हो जाएगा? 16 6 कितना होता है? 80. 80 and 16 will be equal to 96, right? सही है हाँ या ना?
Yes, sir.
Okay, now when you add these things, you will have ये 400 हो गया और ये 70 और 10 180 हो जाएगा. ठीक है. I may use Hindi while calculating because I am more comfortable with Hindi while calculating. Okay, even though I don't know how I grabbed this Hindi calculation, I completely studied in English medium, but I don't know. Maybe in my house, my father used to teach me, my grandfather used to teach me, so they used to always use Hindi while calculations. So I picked it from there only. I remember I was giving a test for a school and I was in 4th standard at that time. And I was learning in an English medium school. I was going to learn in an English medium school, but I was calculating like this only. 12 check 72 and 16 check 96 and like this. So at that time, those teachers, they were Malayalis. We had a school which was run by administration who was from Kerala. So they did not tolerate any Hindi at that time. Now they tolerate right now. My sister also studies there. Now they can tolerate, but at that time they just stopped me and said calculate in English, no matter what I'm writing. But they also were, they were interfering in the process also while I'm calculating. No, you have to calculate in English also. I said I will shut up my mouth and I will calculate in my head everything. Okay. Hindi is easy. If you know Hindi or whatever regional language, I think it will be easier than English because English is kind of glitchy in the case of maths. We have 21. I have to use two numbers to make one number. If you see this. Now, so this is one singular number, right? But for this, I have to say two numbers. 21, 22. It's worse. Sir, I don't know Marathi. But you know Hindi, right, Abdul Hamid?
Yes, sir.
It has been an influence from my family in this Hindi part because I remember my grandfather taught me the table of 15. It was like a poem, and I remember it like that only, like 15 को 15 दूंगा 30 के 50 चौके 60 दम 75 56 90 70 71 28 29 30 So less than 10 seconds it takes to say the 15 table, but it is like a poem. If you have time, spend some time with your parents. Your parents must know some Hindi or some local language and calculations and how to do the tables at least. It will be beneficial. Okay. Now we have got all the information. I need to calculate the mole fraction of glucose. Now glucose is obviously the solute, so chi B will be equal to the number of moles of B divided by the number of moles of A plus number of moles of B. Number of moles of B. What is the number of moles of B? Because we have mass included here, it will be the given mass by molar mass. Given mass is 10 grams. Molar mass is 180 grams. So we'll divide it. And then we are going to have again number of moles of A. This will be equal to 90 divided by the molar mass of water. It is equal to 80 plus the number of moles of solute. It is again 10 upon 180. 10 upon 180. 10 upon 180. Now, if we are going to take the LCM and everything, so this will be 10 upon 180 divided by, I think this will be 90 plus 100, right? Yes or no? I have to multiply, no, this will be 900, I guess. Anna ji, what will be the LCM of 18 and 80? LCM of 18 and 80 will be equal to how much? 180 only, na? So I have to multiply 10 here and 10 here. So it will be 900 plus 10 whole divided by 180. 180 and 180 can cancel. Both of them are a denominator. And I will get the value chi B will be equal to 10 upon 90 plus 910, 910. So approximately what will be the value here? I mean, keep it like this, then you will calculate it at home. Okay? Calculate the value at home, chi B. So if you look at the problem here, the problem of chemistry that we are going to face is numericals with only single number in the question. In the 10th standard, you used to have numericals and they were giving you all the numbers in the question. It was present, right? For example, if you had to use the mirror formula, 1 by V minus 1 by U is equal to 1 by F, or lens formula or mirror formula, I don't remember. So you had been given the V, you have been given the U, and then you have to find the F. Like if they are going to be very tricky, they will give you the R, radius of curvature, and not the F. So you will do R by 2 will be equal to F and all of that, right? But all the numbers were given at least. But as you come to chemistry, I think even in physics, you will have all the numbers given. But when you come to chemistry, it will be a very big problem that there are numericals with only one number. Earlier, you used to either multiply, subtract, divide, do something and get the answer. But right now you have only one number. What will you do with the one number? So you have to understand this one number includes 3 more numbers. As soon as they have written glucose, they have given you 180. And they have not even mentioned water. But you have to assume that there is a water. You understand the problem with chemistry, each and every numerical will feel like something is missing here. Complete information is not given here. And I think you must have faced this problem previously also. Yes or no, guys? Please tell me.
Yes, sir.
You understood what to do, Khudeja, Mariam, and Yasser? Okay. Try to ask what it is asking. They're questioning everything. They don't only want the mole fraction. They want that whether you know what is 10% W by W, whether you know what is glucose and how to calculate the molar mass. So multi concepts are coming in one question itself. Okay. So try to look at these problems very specifically, and when you are doing, try to see what you are understanding from these things. How many numbers are there and how we are calculating things. Okay. Try to look for a pattern everywhere. Now, write the next one. Molality. How are we writing with blue pen? If this is 6. Molality, it is given by, denoted by small m, and it is, please write the definition, number of moles of solute in, or rather I should write per kg of solvent. So m will be equal to the number of moles of solute, that means NB, divided by the mass of solvent in kgs. If you talk about the unit, then the unit for number of moles is mole. The unit for kg is kg, so per kg. You can also see, you will also see something like molal. Instead of mole per kg, they will tell 5 molal solution. So that means mole per kg. Or you will see small m, 5 small m. That means 5 moles per kg. Okay, so all of these, you are going to use this, but in the question, you will be seeing most of molal and small m given. Okay, so you will see molal and m given in the questions mostly. Now, if I look at number of moles is nothing but the given mass of the solute divided by the molar mass of the solute multiplied by Wa in kg. Now, if I look at this particular Wa in kg, mostly you will be given the mass of solvent in grams. So if I want to convert that, I will write it like this. Wa divided by 1000. Because kg is what? Kg is nothing. It is 1000 grams. So I will divide it by 1000. If this is given in grams, I will divide by 1000 and I will get it in kg. Right? Now, this Wa should be in grams. This Wa should be in grams. After this, I will tell you one thing that you have to remember. Denominator of denominator is numerator. What did I say, Mariam? Mariam, what did I say?
Denominator of denominator is numerator.
Denominator of denominator is numerator. So for here, this is my denominator. And its denominator is 1000, so it will be numerator. Got it? थोड़ा खुद से सोच लीजिएगा how it is like that, है ना? Try to understand later on why denominator of denominator is numerator. So molality will be equal to Wb multiplied by 1000 divided by the mass, molar mass of the solute multiplied by given mass of solvent in grams. Okay? So what is Wb? Mass of solute. What is Mb? The molar mass of solute. And what is Wa? It is the mass of solvent. And what is M? M is the molality. All of you got this? Yes or no? Please tell me. All of you wrote this down? क्या नहीं लिखा क्या अभी तक? Anyone still writing? Please say na. Is there anyone who is still writing? No, no one is writing. So this is your 6th, write the 7th and the last one. Molarity with a capital. This is number of moles. Number of moles of solute per liter of solution. Per liter of solution. So I can write molarity is equal to capital M is equal to number of moles of solute NB divided by the volume of solution in liters. Volume of solution in liters. So unit will be equal to moles per liter or molar or capital M. Okay? So you will be using moles per liter. In the question, you will be seeing mostly molar and capital M. Also from here, you can write one more formula that is very useful later on. That number of moles will be equal to the molarity into the volume. Okay? So you have got 4th formula for the number of moles. And when you have number of moles in the context of solution, then you will have number of moles is equal to molarity multiplied by volume. Okay? Molarity multiplied by volume. Now let us suppose you have not been given the volume of the solution, but you have been given the mass and density of the solution. Is right? If mass and density of solution is given. Now, we know that density is equal to mass by volume, right? Therefore, volume will be equal to what? Volume will be equal to mass by density. Okay, mass by density. Now, in this case, I can write molarity is equal to the number of moles of solute divided by the volume that we have been given. So volume is not given, so I will write mass by density. Enough. So for mass, I will write W here because it is. I think this is N. Okay, write it. This is NB, and here we will write W upon D. Both of these are for solution. Again, denominator of denominator is numerator, so I will write molarity is equal to number of moles of solute multiplied by density divided by whatever the mass is given. Whatever the mass is given. All of you got this? Please tell me. Got it, guys? Yes, no? Now, let us see one more. If mass percentage and density is given. Achha, by the way, you can write it like this also. Molarity is equal to number of moles. You can write it as the given mass of solute into density divided by the molar mass of the solute multiplied by the mass of solution. Okay. This is for solution. Density of solution. This is mass of solution. If mass percentage and the density is given, so please see, molarity will be equal to if mass percentage, I will write here X. Okay, so X percentage is given multiplied by density divided by the molar mass of the solute multiplied by 100. Okay, so why is this that I'm writing here? Please see. If you have X percentage of something, then the WB will be equal to how much? WB will be X grams. Whatever the X WB was here, I have written it as X. And what is W of solution? Mass of solution. This was equal to 100 grams. So I have written 100 grams here. Can you see that? Yes or no, please? So this formula that I have written here is not very different from the formula that I have written below. Guys, any problem here? Tell me. All of you understood this? Yes or no? I will write it here. Please see. X is equal to what? Mass percentage. Whatever mass percentage is given. D is density of solution. MB is the molar mass of solute. M is the molar mass of solute. All of you got this? Yes or no? Anji. 100 is 100. Now density of solution should be given in grams per ml. Okay. So wait a second. Not grams per ml, rather it should be grams per liter, then it will be fine. Grams per liter. Now, I don't want you to remember all of these formula. I want you to only remember this form. Okay. I want you to remember this form. I will not ask you, acha ye diya to ye kya hoga? If you remember this formula, that is fine. Okay. M is equal to number of moles divided by volume of the solution in liters. Is everyone done? Yes or no? Please tell me. Is everyone done?
Yes, sir.
Right. Next, the relationship between molarity and molality. ठीक है, ध्यान से देखिएगा. This is very crucial. Don't write anything, just listen. Molality is equal to number of moles of solute divided by number of moles of solute divided by the mass of solvent in kg. Mass of solvent in kg. ठीक है. Let us suppose you have been given the molarity, है ना? And you have to find the relationship. So what is molarity? Number of moles of solute in 1 liter of solution. Clear, guys? Yes or no? Please tell me. Yes or no? What is molarity? Capital M. Number of moles of solute in 1 liter. Don't write it, guys. Say yes or no. Abdul Hamid, Yasir, Mariam. This is clear?
Yes, sir.
Okay. Now, please see. Number of moles of solute, that is NB. If we have 2 molar solution, this will be 2 moles. If you have 3 molar solution, then it will be 3 moles. If you have 10 molar, this will be 10 moles of solute. So whatever the value of M is, the same will be the value of number of moles. Is that right? Yes or no, please, sir? Correct है? हाँ या ना बोले? समझ में ही नहीं आई? Can you guys please keep your mic on? If I am saying the molarity is 2 moles per kg, then what does it? 2 moles per liter. Then what does it mean? 2 mole is present. So whatever the value of molarity is, the same is the value of number of moles. हाँ या ना?
Yes, sir.
No.
Yes,
Right,
sir.
guys. So I can write M, it is equal to whatever the molarity is divided by the mass of solvent in kg. The first plugin I have done, number of moles को हमने किससे plugin करते हैं? Whatever the value of molarity is given. After that, let us see what is this W of mass of solvent in kg. If I talk about mass of solution, this will be equal to the mass of solute and what mass of solvent, rather I should write solvent first because ज़्यादा होता है. ठीक है? It will be equal to what? Mass of solvent plus the mass of solute. Is that right? Yes or no? Please tell me. Correct है? अरे बोलो.
Yes, sir.
हाँ है ना?
Yes, sir. Yes.
Now what is the mass of solute? It is mass of solute there is a relationship. Number of moles of solute is equal to the given mass of solute divided by molar mass of solute. Correct? Yes or no? है ना?
Yes, sir.
So I can write WB as molar mass of solute multiplied by number of moles. Please see. W of A plus molar mass of solute, that means number of moles of solute multiplied by the molar mass of solute. Any problem till here? Any problem till here? No. Now, if I talk about the mass of, this is one thing. This is mass of the solute. Now, also you can see what is number of moles is substituted as molarity. Whatever the molarity was, that is the number of moles. So instead of writing NB, I can write it as mass of solvent plus the molarity of the solution multiplied by the molar mass of the solute. Now let us look at the mass of the solvent. Mass of the solvent can be written as, if I get this mass of solvent, if I get this particular thing, that side, I can write mass of solvent will be equal to the mass of solution minus minus M into MB. I've just taken this that side. Now, what is mass of solution? Mass of solution will be equal to whatever the density of solution is multiplied by the volume of solution. Now, if you look at the volume of solution, we have seen here, molarity is number of moles of solute in 1 liter of solution. So 1 liter means 1000 ml. So mass of solvent will be equal to density into 1000 minus the molarity into the molar mass of the solute. Okay. Now, since we are having this density and this is 1000 ml in grams and milliliter, and this particular thing, that is the molarity multiplied by the molar mass, that will also give you the mass in grams. I have to divide this whole thing by 1000 to get the mass of solvent in terms of kg. So now WA is equal to, we see, molarity will be equal to whatever the molarity is divided by D into 1000 minus whatever the molarity is multiplied by the molar mass of the solute, whole divided by 1000. Again, denominator of denominator is numerator. So the molality will be equal to M into 1000 divided by 1000 D minus M into MB. Okay. Now, please see here, guys. What are these things? What is M? Molarity. What is D? This is density in grams per ml. What is MB? Molar mass of solute. And what is small m? That is equal to molality. Please copy this down.